second now.
Got it.
Okay, I think we're ready, gentlemen.
Yes, go.
Got three of us. We may be joined by others. I'm Baron, Ron Heron, your host for the 81st Numero Ocho y Uno, a weekly episode of the SBAU Astro Hour, big online get-together using Zoom plus YouTube to watch. Several members of our esteemed board of directors of the Santa Barbara Astronomical Unit like to get together every week on Monday morning, and we have for a year and a half, live from our computer rooms and man caves. I call the other guys the Brain Trust. I'm the guy that asks the questions, Vice President Ron Heron, your host for Monday, September 12th through Sunday, September 18th, number 81. This week, I'm going to try to talk about the waning full moon and the night sky. Going to want to see bright stuff out there like Vega and the Wild Duck Cluster and Orion and the Hunting Dogs and the Dipper and the Dolphin, and doggone the shortest day of the year. We got to talk about that. Somehow we're going to lose a few seconds or something. And something really to get scared to get out in the universe. Helpfully, it won't ever come here. Magnetars. Let's meet the guys that are with me here. Jerry Wilson, President. Going to be real.
Hello.
Yep. Hi. We had our meeting over the weekend, and you and I have cruised through, what, 4 or 5 seasons together as president and vice president. I came in late, didn't I? I came in about a year after Adrian Lopez left for Caltech, the young man who was vice president before. Anyway, Jerry is married to Pat Forgy. Chuck McPartland, our outreach coordinator in front of the Ukrainian flag, is married to another Pat, our merchandise manager. And we meet online just like this every first Friday of the month in the evening. We had our business meeting Saturday night online because of the impending possible rain, and we did get a little rain. We also get regular silly science cartoons forwarded to us to our inboxes from President Jerry. And I've got about 7 here that I won't be able to match up with anything you throw on the screen, so I may just have to comment by having Jerry, who's running as webmaster here. There's 2 Toms that didn't join us yet, and Bruce Murdoch is not on screen, but anytime they may come on board as we get ready for what, fall equinox? Is that the 21st or 22nd, Chuck?
Ooh, I don't remember. It's in there. I think the 22nd this year, but let me check.
And I got it down in my head because we kind of got confused a couple of meetings ago. The equinoxes are when the sun is directly over the equator. Is that correct?
No,
it's not. It's just the opposite. It's on Cancer or Capricorn.
no, you're right. It's directly over the equator. You're right. Never mind.
It can be confusing.
22nd equinox, 6:04 p.m.
Okay, that's middle of next week.
It's on the equator heading back down south.
Okay, well, we're not going to wait for Tom Whittemore to join us or Tom Totten or anybody else. The 3 of us can handle all these topics, I'm sure.
Mm-hmm.
Jerry, I don't know where you get those silly cartoons, but don't give out the secret email address or the website, or we'll all get them early and we won't laugh the second time. Here they come. Okay, intro course to Astronomy 101. Let's start small class, and they all have Van Leeuwenhoek's microscopes. There you go. That's the microscopic world versus the macroscopic. Mom said, study so you don't have to wash dishes for a living. So what do we got? A scientist inside a lab having to wash the beakers. Tom Whittemore can tell you about that. Here we go. It was a sad and disappointing day when I discovered my universal remote control, which we all have, didn't in fact control the universe, not even remotely. And Albert Einstein's getting drunk at the bar, and the bartender has to finally tell him, hey, space is curved and time is relative. Yeah, okay, I'm calling a cab right now, buddy. And this one, Houdini, probably you don't know. They say everything, including light, cannot escape a black hole, but they never put Houdini in it. Doggone it, here he comes. I saw, all right, here it is. No doubt about it, Ellington, there's 2 scientists at the board. We have mathematically expressed the purpose of the universe. God, how I love the thrill of scientific discovery.
Now,
Yeah.
this one struck home because when we were studying general relativity as undergraduates, we noticed, someone noticed that Einstein's formula equation for general relativity totaled zero. So we were saying, well, that proves it. The universe is basically nothing split into separate opposing parts.
Is that a pretty accurate, what's the word I'm looking for? Depiction on the board there on the green
No.
board?
No, just the equal zero. All the rest of it is techno babble.
Oh, you know what? I now see what you're talking about. I didn't even see that. Equal zero. Okay. All right. And yeah, here's something Artemis 1 would love to do for NASA. You hit the moon, you kid. My God, you had thousands of miles of empty space around you, and you somehow hit the frickin' moon. Should I? The kid says, should I shut off the engine now? The ignition, sir? And there's a big breath. Student astronaut. All right, now, we a bunch of them. 2 guys sharing the same suit, or at least the same helmet. I don't know about you, Dawson, but I really hate these team building exercises coming out of the psychologist office. And walking on Mars used to be a big dream, except there's a Martian tiptoeing slowly behind him. That is the Steven Spielberg version. Now, this one, it took me a while to figure out exactly what this is all about. The head of a T-Rex above the fireplace instead of a deer. And what is that sitting in the chair but the big asteroid from 65 million years ago, right?
Yep.
He's just sitting in his study enjoying a cigar and a glass of whiskey.
All right, that's crazy stuff.
Okay, that's it.
Okay, you got it, Easy Rider. Well, a lot going on. Mercury stopped in Virgo to start at your beginning and talking points. Friday now begins its western movement or retrograde. I think I understand that's reducing its elongation. That would mean the furthest from the sun in its orbit. It has a elliptical, doesn't it? More so than we do. Mercury.
No, that means that the Mercury switching from prograde to retrograde, that Mercury is passing us up in its orbit. We're passing them up. So, because as they're going around, well, anyway, it makes it look like it's going backwards to us. It's not ellipticity.
How many of our months makes a year for Mercury? Do you know?
88 days.
Oh, wow. Okay, about 2.5 months.
It's the same number of constellations there are in the sky, and it's the same number of keys there are on a piano.
And as Tom Totten says, the same number of teeth that a dolphin has.
I don't know that one's true, but I'll assume it is.
So the difference, the opposite of elongation from the sun would be inferior conjunction.
No, there's inferior and superior conjunction, but there's elongation westward and elongation eastward.
So it's going to do something later this month. That'll be the inferior junction. Moon's almost full. So we've got the bright stuff mostly in the sky to look at this. Something you said about the moon in your talking points. Look at the western sky because the full moon's in the eastern sky. Well, it rises in the east after the sun sets, doesn't it? But then it goes west. So that pretty much the whole damn sky is affected by the full moon this week, or what's left of it. Harvest moon, corn moon. Here we go. We're going to find it.
Yeah.
There's some great pictures sent.
I
It's
get
like
my,
we're getting emails there.
Yeah.
All right. Well, I can give you shine
When we're doing slideshows at Kachuma, since a lot of the people go up there to go birding, we always do the wild duck cluster and the Swan Nebula.
Uh-huh.
Oh, that's what this is about. Wild duck, known as M11, located in the constellation Scutum. Scutum.
Now, this is the sky for September 12, which is today at 7 p.m., and you can see the sun is just set here in the west. That's Mercury, not very high in the sky. It's getting hard to see.
Yeah, good luck for us with the smoke in the air and all that stuff.
Yeah, you've got to have a perfect Kansas skyline here like this is shown. And also the sky is not this dark from my backyard at 7 o'clock lately. Matter of fact, you can't see virtually any of these stars. You'd have to know where to look for Mercury.
So you can only see it for a little bit, and then it goes with the sun.
Yep, it blinks out. It follows this.
Okay, what are all those clustered?
Those are Messier objects.
Yellow things in the middle. Oh, they are. Oh,
Yeah, I've got it set to show Messier objects wherever they are and asteroids. This planetarium software only has a few asteroids and none of them are here. It'll also show the planets if I sell it, which I set it for. And the only one here is Mercury.
That's downtown Virgo, so that's the Virgo supercluster there.
Yeah, right up in here. These are galaxies.
so your
The
wild
best time to see these overhead is March and April. They're too close to the horizon right now.
is that the cluster?
Yeah, well, there's a large number of Messier objects in it that are bright enough for Charles to find them.
Oh, okay. That's all M11 then.
No.
No, this has nothing to do with M11.
Oh, okay. Well, where is Wild Duck?
There.
Okay, in the opposite sky. Oh, there it is.
Yes, they're over by Aquila.
Yeah, now this one, it's supposed to be, it looks like a bunch of ducks flying in formation. I can see a sort of a linear feature there and a dark lane, but I don't see any flying duck cluster anyway.
I think you're seeing too many stars here. If you see fewer,
Yeah, clearly a case of that.
yeah.
Except I don't think ducks fly in formation, but geese do.
No, I think all birds do. I've seen
Oh.
crows do it. Yeah. So this is the summer sky here with the Sagittarius, the teapot, the spout of the teapot with the steam rising out of it of the star clouds in the center of our galaxy. And up here is M11, the flying duck cluster.
Oh,
It's struggling to gain altitude, catch up with the Eagle.
well, all that dust is not a nebula and it's not the side view of the Milky Way.
Well, the dark stuff is dust, and that is the view of the Milky Way there that you're seeing.
Oh, it is. Okay. Don't see it at the top part of the picture much.
Well, that's
No.
because
Okay.
those are the dark lanes that you see. There's molecular complexes there that block your view of the Milky Way.
Mhm.
So
On this program, I can set how deep I want the stars to show up. And if I set it so it'll show a lot more star clouds, then it becomes too chaotic. And so I picked the level where it looks, good to me to pick things out and explain them. So, but the star clouds are there. As a matter of fact, the star clouds of the Milky Way go all the way around our sky.
And M26 there, that's the scutum star cloud. That's that bright area there.
Yeah.
Scutum is a constellation.
Yes,
What is it represented as?
a shield.
Oh, sounds
It
like
used
a
to be
medical-
scutum sobiescanum or something like that. Sobieski shield. So it's a Polish constellation. We need Tom Whittemore here to tell us about it.
Yeah. And down here is Pluto, not this prominent in the real sky. As a matter of fact, you can't see it with the naked eye. You can see the rest of this stuff on a real dark night, which we don't have here. But Pluto, you have to have a scope and you know where to look to see it.
Wow.
He's way down in the corner is Antares, bright red star. And right next to it is a very beautiful globular cluster, M4. These are the summer constellations. They're in the south, more southwest right now, heading for the horizon. They'll soon be replaced with the winter constellations of Orion and the hunting dogs. But M11 is a very, very spectacular. It's supposed to be the brightest open cluster in the sky,
Other than the Pleiades.
other than the Pleiades and the Beehive and stuff. Yeah, that's true.
So now clusters are not star nurseries, but nebulae are. You can get new
Well,
stars.
you often have a cluster in a nebula, so yeah, but the clusters come from nebulae.
I got you.
See, the stars form originally in nebulas like the Orion Nebula. And then as the stars turn on, they're hot and bright, and they have a solar wind that collectively blows all the rest of the dust away. And that reveals the new stars. So it's a second stage after a nebula, but before the stars all go their separate ways.
Wow.
And they just released James Webb photographs or images of the Orion Nebula.
Oh, I haven't seen that.
Yeah, and they're looking through a lot of the gas and dust. So they show a Hubble picture, and it shows all this nebulosity, and then they show James Webb picture, and there's actually a lot less nebulosity, but a lot more stars, and it almost looks like they're showing less. But what they're showing is all the stars embedded in the nebulosity that are forming there in the Orion Nebula.
Well, something occurred to me I thought I'd throw at you as my crazy question of the week, the dust and gas you talk about. When I think of those two things, gas seems to be atoms or molecules. Dust seems to be giant, by comparison anyway, dust particles, which is, my God, millions of atoms. Do you follow what I'm doing there?
Think of the dust as soot.
Okay, but still, it's solid particles. Like
Yeah.
Okay, all right. So, is it all the gases, the elementary gases from neon to argon?
That's a good question. I don't know what the major constituents of the dust is.
Silicate particles and carbon particles.
Yeah, that would certainly be there.
And it's even organic molecules.
Yes, clouds of organic molecules have been found.
Formaldehyde,
Mm-hmm.
alcohol, all kinds of stuff.
So those would be molecular clouds.
Yeah.
Otherwise, we just have to conjecture. We've never gotten any of it, a sample.
No, we get spectra of them.
Oh, it's
some of them glow, some of them, these ones here are stars that we see the light from. The black ones we don't see the light from. That would be a dust. So if some light gets through part of it, we could probably see absorption lines in it.
But now I've heard that for every cubic meter or cubic yard in space, there's a few atoms of hydrogen, for example. It'd be far bigger than that in a nebula, wouldn't it? A gas cloud
It'd still be better probably than a good vacuum here, but much more than open space. Yeah.
And most of the gas would be hydrogen, wouldn't it?
Yep.
A lot of it. Probably what you see here is clouds that span, the dark clouds that span multiple decades of light years. I mean, that's a lot of distance, and it makes them look very dense.
Yeah, if you were in the middle of that, you might not notice it.
Really? I thought about that, yeah.
So I read an interesting science fiction story. I know I've said this before, but back in the 50s when I first turned on to science fiction,
yep.
It was called Neutron Star, and it was by David Niven.
Larry Niven.
What?
Larry Niven?
Larry Niven, excuse me, yes. And he was this rich billionaire that had a spacecraft. Now imagine that prophecy coming true. But he took off at somewhere near the speed of light and headed off into a cloud of dust and gas, and he noticed that things were starting to be missing from the outside of his spacecraft, like antenna and handles and stuff. And so he did some calculation and backed off and stuff, and then he realized from his sensor data that he had flown into a cloud of antimatter, and it was slowly, eroding his spaceship.
Oh, I got to tell you, there's a topic we could take on. You'd lose me, but I got a general feeling about it. It's overwhelmingly regular matter in our universe as we know it, isn't it?
I don't know. There's really no way to tell. There's a professor of mine had a story about that. He said that you communicate with alien race far out in the galaxy, and you exchange information, you learn each other's mathematics, and then you start teaching each other the various views of physics and stuff, and you cover elementary particles, and you cover parity and left-handedness and right-handedness and stuff, and then that you decide that you're going to meet or have representatives meet, and so you go out there, each one in a spaceship halfway between, and he said if the other guy in a spacesuit, now that he knows Earth tradition, if you stick out your right hand to shake his hand, and he sticks out his left hand, don't take it.
Whoa. Yeah, well, I'm totally lost on a lot of that stuff. Well, how can you get an electron that's positively charged? It seems to me
it's called a positron. We see them all the time.
Yeah.
I know, but that's totally anti-physics. Physics as
No,
we
no,
know.
no, physics describes antimatter.
Really?
Yeah.
Have they found places that they think is, a galaxy or two out there that's all?
We have measured the residue of cosmic rays made of antimatter that hit our atmosphere, and by the particle shower it makes, we can tell that it was a positron, not an electron.
Wow. Well, maybe there's another universe right next to us that's all anti, and the two will collide.
It's possible, but I think it's not probable.
All right, this is fascinating stuff, gentlemen. Shine on, harvest moon. Da, 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 da.
Oh, you want to do the moon?
Yeah, let's go out to our good old moon that we can't seem to send our first Artemis to. I don't think it got launched, did it?
No, they're
No,
still working
Artemis-
on sealing it up.
Yeah, they're trying to figure out how it could have leaked and what they need to do. So I heard that the earliest date that I heard was mid-October.
Oh,
Yeah.
for crying out
Now they're
loud.
trying.
There might be a launch today at 3 p.m. from Vandenberg of this Firefly that didn't go off yesterday.
Oh, okay.
Is that a Skylink from Elon?
No, it's Firefly. It's another one of these companies that's trying to do what
Oh.
Musk is doing.
Yeah, I did see that. 3 o'clock. Well, I would doubt that Channel 3 will go to that, but
Well, I've got my computer doing this picture. You all can see. Could one of you read the caption in the talking points? Because I don't have that available.
what, this picture?
Yeah.
Yeah, I'll get it. Okay, astrophotographer Anthony Lynch sent in this photo of the harvest moon, September 2013, taken at Phoenix Park in Dublin, Ireland.
Ooh,
This was an
Phoenix Park in
APOD.
Dublin, Ireland. That sounds interesting.
Sounds hopeful.
Yeah. That's why the sky's cloudy.
Yeah. And the moon doesn't look exactly full, but maybe that's just my glasses. But anyway, it's a beautiful photograph. Thanks, Anthony.
Yeah.
He posted, or it was a astronomy photo of the day, and it was featured on a Facebook page I saw. So anyway, the harvest moon is the nearest moon to the.
Autumnal equinox.
That's it. Yeah. Thanks. I'm tongue-tied here. And if there were a closer moon to it, if there was a closer full moon than this month's moon, then this would be called the corn moon, and the other one would be called the harvest moon. And the reason it got the name for harvest moon is believed to be because farmers have the moon light at night this time of year to help them continue their farming, harvesting and stuff.
right.
So
It's because of the angle of the ecliptic to the horizon. So the moon rises a bit earlier after, it rises at almost the same time each night instead of going almost an hour later.
yes, good point.
Well, I know this time of year is when we get the pumpkins and the squash. I didn't know corn was a late season harvest. I thought that was year round.
Well, I think October would be the pumpkin moon, although I don't think there is a pumpkin moon. But
Well, there's something about it on the horizon. As I sent you that forwarded email, my daughter quoted Neil deGrasse Tyson. We seem to think it's bigger when it's at the horizon.
oh
Yeah,
yeah,
that's
he had a neat graphic showing the moon on a set of railroad tracks, and it was above the tracks, and then it was placed photographically, Photoshop. It was put down on the tracks, and it makes your eye think that it's real small when it's right next to the railroad tracks. But if it's under the railroad tracks and you see it go off to the vanishing point, the moon looks real big.
The moon of what?
The moon looks real big when it's
Oh,
have cues that show it far away. Now the cue in the human mind, we have all sorts of algorithms that process data and send it to the brain. And one of them has an assumption in it that the sky is flat. And you can see that that's true when you look at, after a rainy day, you can see the bottom of the cumulus clouds and they're all define a flat plane going away. And your brain assumes that the sky is flat. So when you look at something down close to the horizon, it must be very far away, and therefore it's very big to be seen like that. When it's right overhead, it's not any farther away. As a matter of fact, it's closer up, so it's very small. And that gives you the illusion of the moon rising being big and the moon overhead being small.
Huh.
And they actually tested that. I mean, people used to think, oh, you could compare it to the size of things on the horizon, like these deer in the picture. And that's what happens. But they put people in these isolation rooms, you know, where it's just totally dark. And they projected a line to represent the horizon. And then they projected the moon in various places, like on the ceiling or on the wall. And they could even get rid of the horizon line, and with no other comparative size features or anything, if your head were more level when you were looking at the moon, you'd think it was bigger than if your head was tilted back and you were looking up at it.
Right.
So it's entirely a perceptive thing that we have in our brains, that the sky's sort of bowl shaped. It's flat on the top, but then it's farther away on the horizons.
Mm-hmm. The universe is very counterintuitive with what our senses tell us it is. And that's one example.
Do you
Okay,
suppose,
what's next?
Naturalists and zoologists will say that the wolves howl at the full moon? Is that true, or is that a myth?
They howl all the time.
Yeah.
It doesn't have to be. When it's dark and there's a new moon, they don't shut up. Although you never know. Harvest moon time.
Yeah.
And it's the hot time of the year here. It's always hotter in September than any of the summer months. But
Maybe.
we're supposed to get a cooling trend.
I think generalizations about the weather are tough. It's always wrong to generalize. All right, I got him. Okay.
All right.
What's the next
Especially now
topic?
too, anything you base on previous patterns of the weather is going to kind of go out the window as we're
Right.
messing with the system.
You wrote that Big Dipper, famous asterism in Ursa Major, is upright and the home of that double in constellation Lyra.
Now this is the Big Dipper with
What's
magnitude limit set so that you don't see a lot of stars. You just see the Big Dipper. And if you look down here, you see that this is a double star, the second star in. And this is a good test for visual acuity. If you can see this at night without any optical aid, unless you need to wear glasses, then you've got pretty good vision.
The names of the stars, actually, Mizar and Alcor, come from Arabic phrases that meant the puzzle or the test and the answer. Because in ancient Arabia, if you could see those two stars, you could be an archer in the army. If not, you were a marcher.
Wow. So there's 7 stars. Is it upside down? I got the impression.
This is, yeah.
Okay.
But this thing goes around. It's an always there constellation for most of the northern hemisphere of most of the U.S. And so it will, at some time during the year, it will be tipped every single way.
But we find Polaris, the North Star, using those upper left in the picture, those 2 stars there. That's one.
The pointers, yeah. Go down here, and way down there is Polaris, the tail star of the Little Dipper.
Wow.
And this arc here goes off this field of view, but you continue the arc and you come to
Arcturus,
yes.
which means guardian of the bear.
Well, you mentioned Mizar and Alcor. Alcor magnitude 4, Mizar is 2.3.
Mm-hmm.
Where's your double?
Well, that's
not
each
here.
of these stars is a double, Ron.
Say again?
Mizar and Alcor, each are doubles. But if you go to Mizar, it's not only a double, but each component of the double of Mizar is also a spectroscopic double.
A spectroscopic double. What does that mean?
Spectroscopic binary. They're so close you can't split them visually, but you can tell they're there by the motions in a spectrum
Are
going
they
back and forth from the motion of the stars.
Are they 2 little red dwarfs orbiting?
No,
They're
fairly
regular.
bright stars.
Okay, but they're just a few light weeks apart or something?
Yeah, they're very close. The Mizar was the first binary system discovered.
It was.
Yeah,
Now we know that more than half of those suckers up there are doubles or triples.
are binaries. Yeah.
Yeah. Jerry's addendum was about something you do, occulting, but apparently we don't have to go there. Maybe at the end if we have time. Triple stars and even more than that.
Yeah.
So these double doubles, that would be 4 total. They're not all together in one like a giant atom in space, are they?
No, there's close pairs that orbit each other, and then those pairs orbit a common center of mass. So
Okay.
2 real close and then 2 a little farther away.
And it's part of the handle.
Now this is an asterism.
Yeah.
And these stars are not gravitationally coupled, but they do tend to fly around the galaxy as a group. And I think it's called the Big Bear Association or something like that.
The Ursa Major Moving Association.
That's it. Yeah.
And it doesn't include the 2 end stars. So the very end of the handle and then the very end of the bowl over there. But the rest of them are moving through space together, and they share motion through space with us and with a couple of other stars like Sirius and Procyon in the winter sky.
Well, what do these 7 stars represent in the bear?
The tail and the rear end.
Depending on whose system of naming things that this is, every culture has their own opinion.
Yeah.
But if it's a bear, at least for the classical Ursa Major Greek constellation, it's a bear with a long tail because Zeus grabbed it by the tail and threw it up in the sky.
And some of the planetarium software I've seen make the Ursa Major look like a cat.
Yeah.
Because of the long tail.
I'll be darned.
Okay, what's next?
Well, there's another part of the sky that has Orion and the hunting dogs high in the early morning sky. The 2 dogs.
I would be reluctant to call that the hunting dogs because that's a constellation that's up by Ursa Major. But yeah, Orion does have 2 dogs.
They're not hunting dogs. That's according
to
the
hunting dogs are the dogs that Boetes the herdsman is chasing the bear with.
Oh, different ones. Okay, well, we start with the belt, the 3 stars in Orion's belt. That's as well as the sword. That's 3.7 degrees south of the easternmost star in the belt, Alnitak, magnitude 1.7. The sword is fuzzy, and it's what, M42?
Yeah, M42 is in the belt.
That's the Orion Nebula. That's the one that the James Webb just took some images of.
And we're getting Orion now more and more, and we will in the winter. We'll see it every night.
It's rising close to dawn. It's a winter thing. We're going to have the autumn constellations before that.
Well, I'm sure this would be my grandpa's asterism. He used to say, son, that's the 3 sisters, point to the belt. And now 70 years later.
I never heard it called the 3 sisters.
Well, have you heard any star system called sisters?
No, 7
sisters.
I mean, that was back in the hills of Arkansas where I grew up.
Anyway, this is the Orion the Hunter, and you can see a description there. It says his bow. And this is the little dog with the bright star Procyon.
Nothing but a hot dog.
Yeah, and this is the big dog with Sirius, the brightest star in the sky in it. It also has more stars. And they are following along after Orion. The labeling the hunting dogs, I'm going to throw Astronomy Magazine under the bus here. That reference comes from their article.
Yeah.
So
are those
great magazine and usually very good information.
One of those stars is Canis Minor. I assume there's a Canis.
That's the constellation.
Oh, that's not a star. Okay.
Yeah, over here, Canis Minor.
But does Canis refer to dog?
Yes.
Yeah.
Okay.
Canine.
Major and minor is big and little.
So we have 2 of the 88 constellations.
Yep.
Yeah, 1, 2, and we have Orion, their master. Which reminds me of a saying that we have around here that dogs have masters and cats have staff.
You're absolutely right about that. Why do we love cats? So, well, 11.4 light years away. Sirius is the brightest star. Is it close by, Sirius?
Well, yeah, Sirius is like 8.6 light years away. Yeah,
Oh.
both Sirius and Procyon are bright only because they're close.
So what's the second closest star right after Proxima? Or not?
Oh, probably Barnard's star or one of those others.
But they call Sirius the dog star, do they not? The
Yeah.
nose, Canis Major, bigger dog. Okay.
So Sirius, the name there comes from an Arabic phrase for something like the sizzling one or the scorching one. And that's where you get dog days of summer, because it's in the sky with the sun in August when it gets hot, and they used to think it added to the heat of the summer.
Oh. Okay.
And in ancient Egypt, they would look for Sirius to rise just before the sun rose, and they knew the Nile River was going to flood.
It's also half the name of a new radio service from space. It's say $15 a month, I guess, in your new cars. It helped put me out of business.
Yeah, and most new cars nowadays do not come with AM radios.
I know. You get to choose from 150 channels or something like that.
Well, they only have a default FM radio, and then you can buy services.
Oh, yeah.
I play my old iPod in my car.
So neither of you have in your Teslas XM Sirius?
No.
I don't pay for it.
Well, you could get probably a scientific channel. I'll bet you they have one. I'm not sure what scientific music would be.
I don't know. The PBS has that Science Friday at noon on Friday, or before noon, because I used to listen to it on the way down to our luncheons at
the
Judge
radio
yourself.
That would be PBS, you said, or NPR?
I think it's NPR.
Oh, yeah. Yeah.
I had my
Tim
radio
Crawford.
input for so long, I forgot what it's called.
Tim Crawford is with us, by the way. He's sort of listening in.
Okay.
Okay, Tim, you got any comments? Throw it our way. You want to come back to the good old solar system and talk about Jupiter nearing opposition? Tell me what that's about. Two of its 4 Galilean moons. One of them is Io. I don't know what the other one is, are supposed to transit across Jupiter. There we are.
We won't be seeing that because that's happening when Jupiter isn't even above the sky for us.
Oh, okay. Well, we'll throw Astronomy Magazine under the bus again here.
Now, see, they make their charts and images for the East Coast. You can see it's 9 p.m. Eastern Standard Time. That's 6 p.m. here.
Oh.
So it's still daytime here when this happens. But the point of this whole thing is that if you're lucky enough to catch a transit of one of these moons over Jupiter's surface, the object Io, and for example here, Io, and its shadow will be very close to each other. And at opposition, the shadow and Io will be essentially touching. They'll be together. It won't happen for very long, but it's getting close to that. And usually when we look at that, we see a shadow on the surface, and then Io, or whatever's doing it, is several planetary diameters off to the side. So that's what's unique about this time of looking at Jupiter.
Okay, what's the other one? The other moon?
Well, all 4 of them can transit, Ron.
What is it?
All 4 of the moons, all 4 of the Galilean moons can transit like this.
Right, yeah.
I understand that, but your notes say 2 of them, and it only gives us Io, and that's
Well, Io and its shadow is probably what they mean.
But there's also another one, I forget, that's going to do this too in this time frame, but I think it's also at the daytime.
All right, let me see here.
So they always
Let's talk about Io.
It's too bad we can't see the little exploding volcanoes on the surface of that little monster.
Yeah, it's
Oh,
talking
yeah.
about 2 Io occultations, 2 Io transits. So
Okay.
both Io.
Oh, it's the closest, right, Io?
Closest to the big Galilean moons.
No, closest to the planet Jupiter.
No, there's other Jupiter moons closer.
You're kidding. Well, are they volcanic?
No, they're too small.
Oh,
They're post-volcanic. They're within their Roche limit. Io is getting close to it. That's why it's being so much frictional force down in it from the different orbit parts of it are in, that it creates a lot of energy, and that's what gives it its volcanic activity.
And that volcanic activity was predicted by Stanton Peele out at UCSB before it was found.
Is that the only moon in the solar system that does that?
No,
I mean, does Saturn have a close moon that erupts?
Yeah, and Enceladus. But
Oh.
those are cryovolcanoes, ice volcanoes.
And they spray water into the space.
Well, that's not the same as a volcano. I mean,
Oh, it's exactly the same.
well, not
It's
Just a
different
different
material.
fluid.
Same phenomena.
okay. So good old Io is transiting.
Besides, the stuff on Io is really low melting point material, like sulfur. So,
Uh-huh.
That's why in the pictures it looks like a cheese pizza.
yeah. And in this picture, this is just a drawing.
Okay. It's pretty close to the way Webb took a picture of it, Jupiter.
Oh yeah, this could be this could be a Hubble picture.
Actually, it was the Webb that sent it to us last week. Remember, we looked at it?
Yes, we
Yeah.
did.
And
Webb shows very nice pictures of it.
wow. Okay, fantastic. So Delphinius the dolphin, we got a quarter hour left. I want to get to magnetars, or do you want to jump to that? Because that's fascinating stuff, the magnetars. And magnetars are us, or the dolphin. That's another, what, asterism? Or is it a full?
No, it's a constellation.
Okay, so it's a jumping porpoise,
Yeah.
Yeah.
50 degrees above the eastern horizon.
I think in this constellation, if I remember right, Beta is the brightest star and Alpha is the second brightest.
Yeah, it's another one of those weirdos.
Yeah.
Okay, Altair is in Aquila or Aquila.
Yeah. Whoop. I thought I had another one of Delphinus. That was better. That's Mercury. There it is.
Might be pronounced Delphinius.
No, Delphinus.
Delphinus. See, there's no I in front of the U. Now it's
Okay.
completely landlocked, surrounded by all these other constellations, right next to Altair, so it's easier to find. It's easy to find.
Now you see those two stars there, Suallicin and Rotanev, that are labeled in the
Right there.
in the
Yeah.
star chart here. Those are astronomy jokes that got put in there
Joke?
by Piazzi.
By
He in Sicily, and the story he put out was that there were some students studying double stars, and there are a lot of double stars in Delphinus, and they realized that most of these stars had names, but these stars didn't. So they wanted to give them names, and they liked their tutor, who was Piazzi's assistant, named Niccolò Cacciatore. So they were going to name the stars after him, but they said, that's way too Italian. Let's take what his name means in Italian and take it into Latin. So it's Nicholas the Hunter. So they had Nicholas and Venator, which is Nicholas the Hunter. And they said, that's still too obvious. So they spell those words backwards. And so you get Suallicin and Rotanev for those stars. And that's the story that Piazzi put out, but he actually is the one that put those names on his star chart to honor his assistant.
So Rotanev is Venator backwards,
Yeah.
and Suallicin is Nicolaus, L-A-U. It's spelled Sualocin, so strange spelling of Nicholas. But there's also Vulpecula, Sagitta, Aquila, Aquarius, Pegasus, and Equuleus, two U's in a word in a row. Wow.
That's the little horse.
Oh. And is that in there? Is that pictured on this
No,
screen?
Right down here.
it just shows the boundaries in the name.
Yeah.
Delphinus the dolphin.
Now that Delphinus fits in good. Oh, especially since Jerry just expanded the image here. The Shumash have a story that they were living out on the islands out there with their goddess Hutash. And as their population grew, they started to get on each other's nerves. And so Hutash said, okay, I'm going to build a rainbow bridge across to the mainland, which right now the Milky Way stands in well for that because it goes over from south to north toward us.
Right.
And she said, anybody who wants can go across and live on the mainland, but don't look down. And of course, some of them got up to the top of the bridge and they looked down and they got dizzy and they fell. And so she didn't want them to die. So when they hit the ocean, she turned them into dolphins. And that's the Shumash story for why there's so many dolphins out in the channel.
And there's a word blue in there somewhere. Isn't there blue dolphins or blue?
No, that's just some fictional story that was written later, Island of the Blue Dolphins.
Oh, I got
Oh,
you. Well, is the lozenge asterism in the middle of this somewhere?
Well, that's the main part of the body of the dolphin. It looks like a lozenge.
yeah. This flattened diamond up here.
That's your
Chuck, what is Osiris? Is that a
Osiris
star?
must be an asteroid, I guess.
No, that would have a number in front of it. I don't know.
Maybe it's an asterism from, I don't know what, because the Egyptians generally had Osiris over in the area of Orion.
The font looks like, and color looks like star names, but I don't see a bright star there. I'm not aware of a star Osiris.
This might be a way they have of enforcing their copyright on stuff.
Oh,
Just like the little false cities that show up in some maps.
oops, I guess I better erase that. Okay.
I've seen that word before. I heard it. Didn't NASA name something Osiris?
Osiris Rex is the sample return mission from Bennu that's coming back.
Okay, that's where I've heard it. And Job's coffin is also another name for the lozenge asterism.
Mhm.
That would be when you look at it, you go, Ricolas.
Yeah, well,
And several of the stars out there are binaries. Gamma, the most prominent, that would be the gamma.
That's the nose of the dolphin.
Okay.
Yeah, that's the one up there. That's a really pretty one. They're both kind of golden color.
yeah.
I think it's amazing. We can't see doubles, the binaries with our naked eye, but you can in telescopes.
Well, there's lots of doubles you can see with your eye, but
Yeah.
you don't think of it as special, I guess.
Huh. Okay. Well, we've done a great tour of the sky. You want to talk about the shortest day of the year? What the hell does that mean? Coming up Wednesday, the 14th, day after tomorrow, NASA calls it the shortest solar day of the year, ladies and gentlemen. It's measured between two successive noons.
Yeah.
Okay.
So how you measure that is you take a stick and you put it in the ground and make sure it's perfectly vertical. And you mark where the shadow is. And then at noon, you mark where the shadow is. And the next day, you have noon again when the shadow comes back to the same point at noon. And when you do that, due to the eccentricity of the Earth's orbit, that varies slightly by a few seconds. And so in this time of year, right down in here, our day is slightly shorter than it is at any other time in the year.
Really? It's not stopping or slowing down at any point. It's still turning the same rotation speed, but somehow.
Right. But this has to do with its orbital speed around the sun.
And we lose 21 seconds.
Yes.
And get a total of 23 hours, 59 minutes, 38.6 seconds.
One of the most interesting things, and also one of the most headache-producing things about astronomy when you take Astronomy 101, is you start out with time and all these different times, sidereal time, solar time, the length of the month, the length of the year, and all these different tilt planes and things that are offset from each other, keeping that all straight. It looks like it's a real tangle of things at first, but after you get a hold of it, you realize it's pretty simple and straightforward. And these things are some of the things that happened way before telescopes were invented.
But all the other days of the years, Jerry, you'd get a little difference, a greater distance in the shadow of the stick.
But it would vary according to this graph that Jerry's showing.
Yeah. In late March, you get something almost as short. The longest day of the year is up here in around Christmas time. And you get another slightly long day around the middle of June. So this is up here.
as far as solar day being that noon to noon.
Now, this isn't how that Greek philosopher or whoever it was that marched across northern Africa and did a stick in the, this is a different thing, determining the circumference of the earth.
That's what he was doing with the well at Syene. Yeah.
Yeah.
Well, he was also getting a different length shadow down near Kenya as opposed to up near Cairo or whatever. However,
Well, yeah, in Greece versus in a well in southern Egypt.
Oh, yeah.
It was when the sun was overhead at the well.
And he used pi, I guess, and determined
Yeah,
how
sure.
far he walked between those two shadows. That's a totally different thing, isn't it?
Well, he measured the distance he walked, and then he knew the circumference of a sphere.
And got it pretty close, didn't he? 20.
Yeah, he's pretty respectable.
Well,
People were
24
smart.
hours, 24,000 miles. That's interesting. Each one of those time zones on the equator is about 1,000 miles, isn't it? When you get up to where we are, there's about 600 miles, isn't it?
6 or 7, yeah. As far
Interesting.
as miles an hour, anyway.
All right, that's fascinating stuff. Shortest day of the year. And the longest is what, 6 months away in December? No, that's not.
No, we're here. It's probably about quarter of a year away.
Really? That makes it confusing.
1, 2, 3, 3 months. So it's exactly a quarter of a
Well,
year.
these are the equinoxes and the solstices it's sort of showing too, you know.
Yeah.
Really? Okay.
Okay, we got Tim helping us out here. He did a lookup on Osiris.
Okay.
And it's Henry Draper 209458b. It's an exoplanet.
You're kidding.
Really?
Well, that can't be what we're seeing.
No, but that's where it is in the sky. So that's
Yeah.
why they marked it there with that Osiris. So maybe you have exoplanets turned on, Jerry.
I think that I've had this soft from before they started finding exoplanets.
But
Except-
don't they do updates
I don't
periodically?
know. It could be.
M15 is to the right. What is M15? That sounds familiar.
That's a globular cluster off the nose of Pegasus.
Yeah, it's a good one too. It's very dramatic.
Yeah, it's
Very
it's
dense.
got a black hole at its core, and it's dimly visible from dark places. There are Arab desert dwelling or desert roving people that have a story that there's a fly by the nose of the horse.
Okay. Black hole. Like a dinky little mini galaxy if it has a black hole in the
Yep.
middle.
Yep.
Wow. And Osiris had to be some ancient, but philosopher. Egyptian, okay.
Egyptian deity. Yeah.
Interesting. Thank you, Tim. It's always nice to have you on board.
Yes, thanks, Tim.
You want to talk about magnetars? Every time I read about these, I get a chill. I don't know what I characterized by powerful magnetic fields. And you're going to have to describe when you put it on the screen what these numbers mean. There's a little curly Q next to 10 degrees to 10 arc seconds with the letter T. It has to do with the strength, I guess, of the magnetic.
The T is Tesla. It's
Oh.
a measure of magnetic field strength.
These things are even more frightening in some ways. What, suck all the iron out of your blood if you get close?
Oh, way beyond that. All the atoms would be forced by the magnetic field to be long slivers. They would not be spherical or round or anything. And the energy levels would change, so biological processes would not be possible. And organic molecules would not be possible.
Huh.
So it's something that there's different ways of developing a magnetic field. For example, you can have a lump of charge that moves in a circular orbit. Like if you take a wire and you run electrons around this wire, that creates a donut-shaped magnetic field around the wire. And so there could be something under the surface of a neutron star that has this ability to conduct. It could be a lot of little local loops that are making their own magnetic fields, but they all, for some reason, coordinate and add their magnetic fields to make a net vector sum. The interior of a neutron star is key to what kind of magnetic field is generated or how it's generated. Some things I've read claim that there is a proton superconductor lattice inside, or a lattice of liquid. So there's many ways to get this, but it starts from a star that probably has a magnetic field, and then it collapses, and the mechanism of producing the magnetic field collapses with it. And so it's like a skater that speeds up because the magnetic field strength is equal to the velocity of the circulating charge. So if the charge all of a sudden speeds way up, the magnetic field will get much, much more intense. So that's all I know about it.
But a neutron star, my understanding is it's gotten so packed together that all the protons and electrons get together and become neutrons, right?
That's why it's called neutron star.
And why would that generate magnetism? Maybe I missed part of your speech there.
Oh, that's not understood how the magnetism comes out. There's several ways to create magnetism that we know about. One is to take a current loop, a magnetic or electric field. Electrons go around a circular wire, and that creates a donut-shaped magnetic field, like the one you see over on the magnetar. That's a donut-shaped field.
Yeah.
Also get the field produced in a piece of magnetic material, like samarium or iron. And that's all the little atoms in it. The electron going around the nucleus, that's the current loop that produces the magnetic field. But in most materials, these are all randomly oriented, so there's no net magnetic field you see from the outside. But you can make all of the magnetic field lines in an iron. You can make all the atoms line up by putting it in a strong magnetic field, and then they all line up. And then when you take it out, it retains that magnetic field until you re-randomize the atom, say like hitting it with a hammer or heating it up. So it could be a collective effect inside here. That's the Earth's dynamo is sort of a hybrid between the two. We have current loop areas in our core, but there's a number of them, and they add up, vector sum, and sometimes they add up to cancel out. And that's what happens when we get field reversal, is that some of these things start turning over, and so the vector sum is no longer appears to be a simple magnetic field. And we've seen that already in some places on the Earth. The North and South poles have already reversed in some areas.
And Ron, it's not like the neutron star is entirely neutrons. So there are some protons and things kind of swimming around in there, and maybe more exotic particles that would carry this current.
But my understanding, everybody's understanding, is that it involves metal. When you say a wire, it's made of metal. They don't make it out of.
It involves electron motion, charge particle motion. I just said like in a wire where the electricity goes around, but it could be a beam of electrons. You shoot electron beams out into space. That beam will produce a magnetic field around it.
Yeah, you can have magnetic hydrogen. You can have metallic hydrogen, and they call it metallic only because it will conduct charges and give you a magnetic field if it moves. So,
what about silicon?
Silicon's an isolator.
Non-conductor.
What do you call it? Insulator.
Yes.
Yeah,
it's a semiconductor. So
things like
its magnetic field lines, microscopic field lines, do not add up, and they can't be made to add up. So it's a non-magnetic material. The interesting enough, if you're sitting in space and an electron goes right by you, you will see the magnetic field produced around that electron as like a halo ring. Now, if you have the electron sitting still in space and you go rushing by the electron at a very high speed, you will again see the magnetic field around the electron, even though the electron is not moving. It's the relative velocity that gives it its magnetic field. So you would feel the magnetic field if you were going fast. So an electric field coupled with speed is the source of magnetic fields.
So bottom line is, if we ever get to cruise around the galaxy in spaceships, we don't want to get too close, not even to orbit a magnetar, do we?
Oh, you will tell you're getting near it way before you get there.
Really?
All your compasses will point at it.
Well, okay, and they're rare? And they're powerful and they're dangerous.
They're powerful and they're dangerous, and I don't know how rare they are.
What are the wings on those two right? The one in the middle and the right. What does that mean?
That's where it's beaming radio energy or something. It could be particles out. So that's a jet.
Okay.
That comes from the poles of the object.
And the
Poles
one
of
of
the magnetic field,
Yeah,
which may not correspond with the rotational axis. So that's why you can get a pulsar.
right.
oh, pulsar. And the one on the left that doesn't have it, is it the beginning to become?
Yeah, that's just a magnetar.
Oh, it's a magnet. Oh,
These are all different configurations. You can have a magnetar by itself, you can have a pulsar by itself, and you can have a magnetar pulsar together.
well, a white dwarf is remnants of a star that's pretty packed together. Would it become a magnetar?
No, it's not a white dwarf. It's not a neutron star.
Okay, but it's about the same size and just as heavy.
No, it's bigger.
Oh, it's bigger.
A white dwarf is the size of the Earth. A neutron star is the size of a city.
Yeah.
Oh, with the same amount of mass in it.
The white
Potentially.
dwarf still has atoms in it. It's not all neutron matter.
Okay, so a magnetar might be the last step before black hole.
If you add more mass to it, you can get a black hole.
Yeah.
Interesting. Different neutron star type. Wow. Okay, gentlemen, you dazzled me again, and Tim Crawford. And I don't know what happened to Tom Whittemore, but we missed him, and he'll be back on next week. And real quickly before we go, we got two things happening on the night of the Westmont College Friday, don't we, Chuck?
Do we?
I think you said something was going on at the board meeting Saturday night. If we have time, what is this we're seeing on the screen, Mr. President?
This is a picture of a magnetar.
Oh, it is?
Yeah.
And it's yellow.
No, it's just this is the dust around it. The magnetar's in there.
Wow. Used to think, what if you had metal moons? Metal moons might orbit a magnetar, except it doesn't work that way, does it?
Yeah.
No, in order to orbit, you need a spherically symmetric gravitational field or force field of any kind. The magnetic field around the magnetar would be toroidal. And while we did have a math class where we had to figure out the orbit of things in a toroidal gravitational field, it's not likely to occur.
Yeah.
But I'll bet you if you tossed a lot of iron filings in one, it would have a Saturn-style ring. Perhaps.
Not very close to it, no. I think those are pretty fanciful.
Well, thank you very much. We're going to talk about that again, and we'll get into that matter next time. And gentlemen, we're supposed to have a cooling off period, so enjoy it. Take care of yourselves, and we'll do it again, I guess, next week. Number 82 coming up. Jerry, Tom, Chuck, and the cat.
Yeah.
Say hi to your
Gatto.
wives, Pat. I can say it one time. Say hi to Pat for both.
Okay.
All right, thanks.
Bye.
Thanks, everybody.